So this talk is going to be my story about how I started with the Yardstick 1. It's going to be mostly a beginner's guide, and I'm hoping it can help you guys a little bit, although that might be hard without projector. I'm 18 years old, right out of high school. I pretty much knew nothing about the Yardstick 1 when I started. Nothing about cars, nothing about key fobs, nothing. So my goal was to find a summer job. I ended up working with CAN Bus Hack. It was founded in 2010. They work with OEMs, suppliers, aftermarket companies, and they reverse engineer and analyze vehicle systems. It was founded by Robert Lealy, based in Detroit. If you're interested, you can go to their website, www.canbushack.com. And they're basically leading the car hacking village right now. So to start talking about Yardstick 1 and RF, you have to know about remote keyless entry systems. Basically, your key fob works by transmitting an RF code, normally encrypted, and it normally uses rolling code, to the car. And if the car agrees with what it receives, then it's going to work. Otherwise, it's not going to work, obviously. And you have to know a little bit about RF, too. A lot of the time, it's just simple. There are different types of modulation that you have to know about. The simplest is probably ook. It's just on-off keying, where basically it's binary. A high pulse represents a 1, a low represents a 0. And you can use that to convert it to hex. You can view it with RF cat and the Yardstick. More tools you'll need Python and Linux, basically, because RF cat only supports Python scripting, and it only runs in a Linux environment. So they're both pretty simple to learn, actually. I didn't know anything about them when I started, and now I do. Hardware, you're obviously going to need a computer, a car and key fob, and then it really helps if you have a software-defined radio or SDR, but that's not necessary. You can do it without one. And then a Yardstick 1 or some other RF cat supported dongle. Probably. Cat, sorry. Tango. T. All right, and then for software, you're going to need Linux to be running on your computer. I used GQRX for my software-defined radio, although you can use whatever you prefer. I used Audacity for WAV files, viewing them, and then obviously RFCat for the Yardstick. And for RFCat, it really helps if you also have IPython installed on your computer, because it allows for tab completion and just other useful functions. So starting off with the hardware, RTL SDR, it's cheap. You can probably get a dongle for, I think, $20 on Amazon. And all it really does is receive RF signals. It's that simple. You want to be using it with GQRX, which is your software that converts the RF signals to something that you can view, basically. So I have a picture of it here on the slide. Obviously, there's no projector here, but you'll be able to see all of this on Car Hacking Village website, including the code I have. Basically, it's the other half of a software-defined radio. So it allows you to demodulate with AM, FM frequencies, all that fun stuff, modulation, sorry. And what you really want it for is it can save whatever you're transmitting as a WAV file, which you can then open in Audacity. And that's why you want Audacity, for viewing WAV files. When you look at it, it'll be just like a basic wave function type thing. And what you want to use Audacity for is finding the baud rate normally. That's what I do. And also it helps when you're looking at what modulation is being used. And it's also helpful once you actually have your Yardstick 1 working. It's also useful for comparing the signals that you're transmitting to the signals that you're receiving and making sure that everything's working the way you want it to, all that stuff. Yardstick 1, it can receive signals. It can act as kind of an SDR in that respect. But it's really useful for transmitting your signals. And that's what I used it for. I've been using it to jam signals from the key fob and to emulate the signals. Basically a roll jam attack, which is what I'm going to kind of go over here. So RFCAT is basically to the Yardstick 1 what GQRX is to the SDR. It's the software that makes the hardware work. IPython really helps. You can't do tab completion without it. It's a ton of other features it just adds. Basically a Python scripting environment. What I did, my script actually only works on my car. I probably could have done more if I had more time with it, but right now it only works on the '02 Chevy Impala. Basically, my key fob, it has pulse width modulation, which is a special type of on-off keying where it bases you get a 1 with 110 transmitted and a 0 with 100 transmitted. So it's basically the same, it's just a little different, and you have to take that into account when you're writing your Python script. Half of my signal it's key-locked encrypted, and then half of that signal is rolling code. The other half is just static, the serial number, what button you pressed, voltage monitor, all that fun stuff. And with all that, I guess getting started actually hacking the key fob. So what you first want to do, you want to find your FCC ID on the key fob. It should be there somewhere. If it's not, you can find it online. But FCC requires all of the key fobs that can be sold to be registered. And basically, you can just type fcc.io / the key fob, or the FCC ID, and you can find everything you need there. Normally, you have the frequency that it transmits at. Sometimes you can find the type of modulation that's being used. Baud rate is occasionally there. I found the schematic for my key fob, which was really helpful, actually, because that allowed me to find the documentation for the chip, and that was really helpful, actually, figuring out what the code was supposed to be saying. So the easy part is using the SDR. All you have to do, you set that up in GQRX, find the right frequency, hit record, or choose where you want to record the file to first. Hit record, and it'll save it for you as a WAV file. And also set it to AM demodulation, and then record the WAV file. Then you want to open that WAV file that you just recorded up in Audacity. Mine was pulse width modulation, so it would look a little different from on-off keying or any of the other modulation types. But basically what you want to do is you find the baud rate, which is going to be the amount of bits per second. And you can do that. It has a little timer thing on Audacity does. It has a little timer thing, and you can measure from where one bit starts to the next. It's just either the blip, the 1 or the 0, on or off. And you can use that to find out your baud rate, which you'll need for your yardstick 1 once you start an RFCAT. So the yardstick 1 is where it gets a little bit more difficult. You have to set everything up, all your settings, your baud rate, your frequency, type of demodulation you want to be using, all that fun stuff. You have to set that up before you can even receive the signal. It runs with Python scripts, so you can import your Python scripts, which is really helpful later on once you actually start doing replay attacks and roll jam attacks. And it's just the hardest part really is RFCAT, because there's no documentation for it, so you kind of have to work your way through it. If you're interested in doing something with it, you have to go through the source code, figure out what it's trying to say, and then how you want to do it. But I guess I should probably start with the first attack that I did. It was just a really easy signal replication attack. Basically, you take your key fob out of range of the car, so the car won't be able to receive the signal, and jump a counter on the rolling code. And you can use the RFCAT to record that signal. I could show you, but no projector, sorry. You can come talk to me after, too, if you want. I can try and show you. But you can record the signal that's transmitted and basically just transmit it right back out. So that's the easiest way to do it. A more complicated attack is the roll jam attack. So the concept here is when whoever you're attacking presses the button on their key fob, you jam that and steal the code from it. And then they're confused, why didn't my car unlock, all that stuff, so they press the button again. And this time you transmit the first code you received and take the second code. So now their car is unlocked, and you have the next code in the rolling code counter. So then obviously you can just unlock their car with the press of a button. And the hardest part of this part was actually the timing. Because the way RFCat receives packets, it receives an entire packet, and then it can transmit. It can't be in receive and transmit mode simultaneously. It can only be in one. So you either have to receive the entire packet and then try to transmit out your jamming signal before it reaches the car, which is just about impossible. Or you have to modify RFCat a little bit to get it to record only part of the code, or however you find that it works with your key fob. The way I did it with my key fob, the first part of the code that's transmitted is actually the rolling code. So I was able to cut it off there and just grab that rolling code and add the static code on the end. And there's a CRC obviously checking just to make sure that all of the code's right. But what I found with my key fob is that it only has 4 possible CRC values. So I could just kind of throw them onto the end and throw the code out there. And one of those was going to work. So that was basically my roll jam attack. It would be better if I could showcase it. Yes?
So did you have to recompile and redo the RFCat source code?
No, I was not recompiling the source code. There's a function, or not a function, a feature of RFCat that lets you choose the length that you want your packet to be. And that way I was able to just say, hey, take half of this packet, because I know how long the packet is. It's going to be the same length every time. Take half of it, the first half, and then ignore the second half, just start jamming. Yeah, there's a very large amount of functions, so you can do pretty much anything. Basically, since I can't show you guys anything on the slide, this is the end of my presentation. I am going to give some credit where credit's due. The Hack 5 team on YouTube helped me out a ton with their introductory videos on the Yardstick 1. Michael Osman obviously made the Yardstick 1. It wouldn't be possible without him. Atlas of Doom for RFCat. Sani Kamkar, who actually, I believe he was at DEF CON a couple of years ago, who did a talk on this exact same idea. He didn't do it with the Yardstick 1. He had his own device that he made. But the roll jam attack was all his idea. Andrew McPherson, I got some code ideas from him. I believe he has a blog, Andrew Nohawk. And then obviously Robert Leali for hiring me for the summer and making me work. So if you guys want to know any more, I can try and help you out. Take a look at what I have if you want.
Yeah, I'd love to.
So yeah, if you just we've got a couple minutes in here. I can do it, right? Yeah, it looks fine. And otherwise, we can probably go back to the car hacking village and set up somewhere. All right, but that's it for my presentation.